Hey everybody, welcome to Perspective 101. This is still 3-point perspective, but we are going to supplement some of the other tutorials right now with just sort of trying to fill in the gaps. So you can't cover everything about 2-point in a single perspective video. So we're going to cover some other topics that hopefully will fill in those gaps. So let's get to it. So first thing is just understanding the space, right? So there was an assumption that you guys already knew what the triangle was at this point. So the triangle consists of 3 vanishing points. And let me get, so we have V, hold on. So this is going to be the left vanishing point, or X, the right vanishing point, or Y, and the Z vanishing point, or the vertical vanishing point, or Z. Okay, and with this, we can actually create this triangle in many different ways. The one thing to note is that the angle between each of these cannot ever exceed 90 degrees, right? So this would not work because then we could not find from this edge here or from this vanishing point to the opposite horizon line as taught in the other lessons. Also, you'll find that there are some angles that just don't work if we get too low, right? So if this angle is lower than like 25 degrees, then it becomes a problem. It's probably more like 40, but as long as we can go from one vanishing point to the opposite side and meet at a 90-degree angle, that's all that really matters. Another thing to note that this horizon line up here is called the true horizon line, and it is in fact the eye level. This particular case, which is what we talked about before, this one is looking downward because our vertical vanishing point is down. But if my triangle was facing upward, then we would be looking up, and this would still be eye level. And what that means is that eye level works with our height of our eye. So if I have a 3-foot person, then this would be 3 feet in the air. If that 3-foot person was on a 3-foot box, then this vanishing, or this horizon line, would be 6 foot in the air. If it's a 1-foot person on a 25-foot box, then they would be 26 feet high. So right now, in this particular case, we are either 6 foot or we are 3 foot. Because we've decided that, so that means that our horizon indicates the level at which the person viewing the scene is at. Okay, so if I'm a smaller person and I'm looking downward, then I will only see things that are below 3 feet. One thing to note is that if I am looking down, I will not see underneath these cabinets. I will not see underneath these cabinets. I will not see the ceiling. But if I am looking up, chances are I am seeing underneath, but not the top of them, right? So it starts at eye level, and if I'm looking down, I'm looking on top of things that are still below me. And if I'm looking up, I'm looking at the bottom of things that are still, that are above my eye level. Now, the cone of vision will not reach your horizon line if you're looking up to any degree. If it reaches the horizon line, then your picture frame will encompass the eye level and above. But in general, usually if I'm looking up, I will be looking up. I will not be looking forward, and I will not be looking down. So if I am looking up, then I will probably no longer see the floor. And if I am looking down, I will no longer see the ceiling, right? So if I'm looking down, if I'm a 6 foot tall person and I'm looking down, I will definitely not see the ceiling, right? So if this is our cone of vision, and this is what we're looking at, then anything that's outside of here, I will not see that stuff. Now this over here is my left horizon line, and this over here is my right horizon line. Now the reason why we have 3 horizons is because, man, I don't want to get too much into history, but essentially the math works out this way, and it was the appropriate way of connecting your vanishing points so that mathematically you can create your measure points. So there must be 3 horizons. Also of note is that this triangle can be rotated and it will still work, right? It can be rotated on any of these sides, right? So the horizon lines will still be horizon lines. It's just a different horizon line will be a true horizon line. So I can create a 3-point perspective image, and as long as one of the horizons is represents the eye level or the curvature of the Earth or the level plane, right? So that means all objects are flush to this. So even if it is sideways, then we'll just have a dynamic angle. But one of the horizons needs to be the true. So that, of course, is important. Then another thing to note is where you place the V, the vertical vanishing point, or Z, really, really matters. Okay. To the right, if this is center, somewhere to the right of center means that we are going to have a right-heavy image. So depending on how we rotate the object is how we're going to see the space. So if the vertical vanishing point were in the center, then the center would be here, and then the object might be flush centered, right? But when we place it off to the side, our object is either going to be like this, or our object is going to be like this. And the reason why that works out is because we're either going to our right vanishing point, and usually what I find is if people put the center of vision to the right of center, they'll do this first. They'll put the long end going back to the shorter space, and they'll put the short end going back to the longer space, which tends to, like when I frame this, the eye tends to fall off the page. However, if I rotate it the other way, if I rotate the long edge going back towards X, and then the short edge going back to Y, Y is just at more of an angle right now, then when we create a composition, it tends to feel more balanced because of the way that the visual weighting works, right? So that's just something to note. If the vertical vanishing point was to the left of center, let's say it was over here, then I would have the same issue if the long edge was going towards the closest vanishing point, right? So I'm using this as my vanishing point down here now. Then chances are our eyes will tend to fall off the page once I start framing it, because the depth is so sharp that it just pulls the eye right back to that vanishing point. However, if we put the longer edge going towards the further vanishing point, then it gives us a less sharp angle going back in that space, and it tends to hold the eye. So just something to consider. Now, if I frame this, this is going to give me a much more pleasing composition. I have a much more, it's much more likely that my eye is going to stay on the page over the other way. So based on where the center of vision is, or where the center line, in this case it's going to be our vertical reference line, where that's at really matters when it comes to the direction that we're looking at it. So in the center, we're somewhat looking centered at the object. When we're on the right, we should be looking more at the left side, and when we're on the left, we should be looking more at the right side or the long side, right? So I oriented the same object, I just oriented them different. So usually my focal element, I'll put the longer edge going towards the further vanishing point in order to give us a better perspective. Now here's also another thing to note, that we can only have one center of vision. So I'm estimating this to be at 90 degrees. I would definitely advise not estimating this, but I'm doing this for illustration purposes. Now I have my center of vision. My center of vision is where we calculate everything from our station points, right? This is where it starts getting really hectic, right? We calculate our distance lines, and then we find our station points by calculating the angles here, right, at 90 degrees at the eye. When we find our station point, that station point to the vanishing point now creates, right, we swing it over, and on the opposite line is going to be our measure point, right? So we've covered all this stuff. Because of that, this is the only space that we can create a cone of vision, all right? And as a result, hold on, let me put on shape. As a result, remember it's the halfway point from the center of vision out to the station point, so it's halfway. And if I'm using this center of vision in 3-point, and these distance lines, which means that I'm using those measuring points, then whatever I draw in here, as long as I'm foreshortening units based on the center of vision here, then the space, the depth will be correct. So if I move this center of vision over here, then it's no longer correct, because that center of vision is the only place in the whole entire scene that we know exists a certain distance away from the eyeball, which is the station point. And because of that, this is the only place that we know actually exists that we can measure and foreshorten units onto the reference lines, right? So I've seen many different people do many different things. Like they might just say, hey, this is where I want, like the front corner of my building, and then they'll start making a new, and I've seen this multiple times, they'll start making a new center of vision, and notice how they do not meet on the other line at 90 degrees. You cannot do this and still make a measure bar and a true height line and then foreshorten those units onto those reference lines, because they don't exist on the picture plane. Only this exists on the picture plane. Everything else does not. So what we do is we foreshorten our measure bar onto these reference lines, and then if we need to move or we need to create another 0 point, we have to actually project them down and back and over in space onto these separate lines. And what that will do is, if we're using our vanishing points, is it will properly move those points back in space at whatever space it is. So these 3 units are smaller back here because I projected them downward. So if these are foreshortened even more. And then if I want to move them over to the left, I can do that. And then if I want to move it down again, I can do that, right? So wherever that is. So I'm just triangulating all these things. And then this is, so now we're going down here, then over, and then down again. And then that will give us these units right here. It will push them down, back, and then over, and then we can find those units there foreshortened properly using this cone of vision, using this distance of a distance line, using those measure points created from this distance of the station point to the center of vision. So once you set this up and you find your center of vision, everything is calculated from the center of vision. You cannot change that. It's just how it works. In 2-point and in 1-point, it works a little bit different. We have more latitude for that because the picture plane is flush with the ground, or it's perpendicular to the ground, whereas this one is at an angle from ground and walls. And so the only place that we do have that we know exists is the center of vision. So I'm going to remove some of these. We're going to go back a little bit. And I want to actually just move points around in space. So the first thing we're going to do is I'm going to fake foreshortened units. Okay, I'm just going to do this as if I made my measure points and as if I foreshortened them. Okay. Now what I want to do is I want to take those foreshortened units. Here we'll forelengthen them as well in front. Notice how they get bigger. This is just a pattern. They get bigger as they go forward and they get smaller as they go backwards. So let's say I want to move this point right here. I want to move it down by 2 units. So I have to do also, I have to do foreshortened units on this bar as well. So again, I'm faking it. Just remembering some of the patterns that I've been able to see over time. So now we have these ones are going back in space, these ones are going forward in space. So let's say I want to move this one down by 2 units. In order for me to do this, I need to find 2 units down on Z from this line. So we'll go 2 units down, and then I'll draw a line back to Y because I want to take something from the Y reference line and I want to bring it down. Well, I can't bring it down perfectly vertical. I have to actually take this unit and project it down to the vertical vanishing point. And now I know that this point in space right here is in fact 1, 2, 3, 4 units positive or negative to the right. So we got, this is 4 units, and this one is triangulated 2 units downward in space. So now we have 4 on the Y and 2 on the Z. Now what if we want to move it backwards? So now we got 4 over to the right. We've got 2 down, but I want to move it backwards in space. How would I do that? Well, I need to have my foreshortened units on the left as well. Now these will foreshorten less because it's further away. So we can fit more units on here. Anyway, regardless of the pattern, so you're seeing me do this, I don't want you to get caught up in what I'm doing right now. I want you to get caught up in how I am taking each of these and figuring out their distance, right? So now I want to take this back. I want to take that unit. So we did 4 to the right and 2 down. Now I want to take it 2 to the left and back. So if I do that, I cannot just go 2 to the left and go over and say that this is that point, right? I can't do that. I actually have to triangulate that again. So now we'll go 2 to the left, and then we'll go 4 to the right. And then where this meets, we've got 4 to the right and 2 back. So now we can go downward in space, and where it hits that red line that was 4 units over and 2 units down. So this unit is 4 units over and 2 units back, right? So 1, 2, 3, 4, and then 2 units back. That's 4 units to the right, 4 units y, 2 units x back in space. So that means that this line right here, all the way down to z, is 4 units over and 2 units back. So 1, 2, 3, 4, 1, 2. This line going back in space right here is 4 units over and 2 units down. So now we now have this point where they both connect at 4 units over, except this one is 2 units back and this one is 2 units down. And so at 4 units to the right, 2 units down and 2 units back, we have this point. So now this point right here is now 4 units x, or 4 units y, 2 units x, 2 units z. That's what that point is right there. And that is how we move measure points or units. That's how we move them from one place to the other. So if I know that, let's say I decide that my center of vision is right here. How many units over? That's 1, 2, 3, 4 over. So that's 1, 2, 3, 4. So if it's 4 units right over, that means that if my eye is at 6 units, I am looking at this degree. I'm looking down at that degree. So remember, 4 units in, and then 4 units in here, and then I decided that it was 1, 2, 3, 4, 5, 6 units in front. And if that is the case, and that's what I decided, that means that this will give me my measurements. So now I could say, based on my foreshortened units, had I done this with a linear measure bar, right? Had I done this properly with a linear measure bar, I can now say that the front of my table is 2 units x, because x is to the left, and this is to the left of me, right? So that's to the left of center. So 2 units x, and this one is y going back in space. And then it is 1 unit y. So 1 unit y back in space, 2 units x, and then we will meet this corner right here. So it's just slightly in front of that. So if we go 2 units y, let's give a different color. Let's do this in purple. And I will get rid of this. Oops. My bad here. I put all this. Here, let me just remove these units here. Put these on the layer that we need them now. Okay. So now if we want, hold on. If we want 2 units x, right, what did I say? It was x was going, y is going this way, x is going that way. So y is left in, is as from the front to the back of the room, and, or sorry, x is from the front to the back of the room, and y is from the left and the right of the room, right? And z is from the up and down. So we got up and down. So now, if I decided that this was my center of vision, which is 4 units over, and 4 units in and 6 units forward, then I need to just calculate relatively. Actually, I decided it was right there. Didn't I? Here, 1, 2, 3, 4, 5, 6. Yeah, that was right. So I decided relatively that we had 2 units back on y and 1 unit back on x. And then the front corner is from the eye, it's 3 units down, right? So the eye level is right here. So we got 1, 2, 3 units down for that front corner. So then I would go over 2 units x and then 1 unit y, right? So 1 unit y would be here. And then 2 units x would be here. So now we have this guy right here. And then 3 units. Actually, it's only 1 unit from the center of vision. So it's 1 unit down. It's 3 units down from the eye, but 1 unit down from the center of vision. So then we'll go 1 unit down right here, and that can be calculated by going in this direction and then coming down in this direction to triangulate it. And now we've got that point in space going back, and then all we have to do now is go down. So this is how that worked. Let me do this in a different color so you guys can see it. So this one is on the XY plane, and I'm getting 2 units back and 1 unit to the right. Actually, we can do this. We can go from the X plane backwards on 1 because we want 1 unit down, and then it's 2 units back where this unit needs to be triangulated, so we'll go 2 units to the left, and then where they are triangulated, now we have 1 down and 2 back, and then now we need to go 1 back in this direction, and the only way that we can do that is by triangulating that third point, which is out here to the right and down. And then now where these two connect, this is the front corner of my table because it is 1 unit to the right, 2 units to the left, and 1 unit down. We have to triangulate these things. And then now I could decide that this is 3 units over to the right or to the left, which is on X. So now let me add another layer here, and then we can make sure that we're triangulating that point on another layer, so it's easier to see in a minute. All right, so that's the point right there in space. That is the front corner of that table. Now we need the back corner, which is it is now 3 units to the left. So that's 1, or actually if this is 2 units back and to the left from center, right? Then this is 3 more. So we have 1, 2, and then 1, 2, 3 to add to the back of the table. So that's where it would be at there. And then on the right hand side, we only have, it's going to be coming forward in space, so we don't have to worry necessarily about that. We just have to worry about where it's going to meet 1 unit back, 5 units to the left, and then 1 unit down, right? And then once we have that, we can then build the front of our table and move it forward in this direction. And then we'll know that that's the front. We don't need to worry about the back because it is outside of the view. Right. So let's make another layer. Let's go down like this. And we decided it was 1 unit down. And then we'll take that point in space backwards. And we'll take this one backwards as well because now we need 2 units over. So basically what I did is I calculated downward. Now I'm calculating to the right 1 unit, and then I'm also calculating from that unit down. So in 3 different axes, I now have the point back in space that equals the back part of that table. So I'm triangulating this space based on what I know about the space. Now what I did in the other video tutorial towards the end was I took alright, so now we have the front. I'll explain that in a minute. But now we have the side closest to us, and now we have the side furthest from us. And then we can bring this down and create our little box, and then we can estimate the top size of that. And now we have a little table at the distance and size and perspective that's foreshortened appropriately And the reason why I'm leaving this backside is because now we have to find out how tall this is. So we have 1, 2, 3 units from the top. So if this is 1 unit down, then we need 1, 2, 3 units down. But here's the rub. I can't just bring this unit back. I also have to bring it back by 1 unit as well. So we'll bring this back by a unit, and then we'll grab this point right here and then bring it over. Because now we're back by a unit, we're back by a unit down here, and then where it crosses the table down there is 3 units high. And then that is where it looks like where this line right here crosses that one, we wouldn't see that back leg. We would only see the front leg of this table. So this really helps with foreshortening a space. But what I was saying is in the previous tutorial, I actually used the physical object to reverse engineer the space, and that is very valid, but I found that too many people were confused by that. So if you just foreshorten the space and then you decide how far back the object is from the center of vision, you're going to have better results. Or you find out how to get to your actual grid, right? So you find your grid and then you start building it, right? So if I wanted to make the floor grid, I would only have to actually build the floor grid that's in view, right? So I'd only have to build this grid right here. And so you'd have to find from the center of vision, you'd have to find the floor. So I'd have to find the floor. I'd have to triangulate where the wall is on X and Y, preferably the back wall and the side wall that's going to be in view, so whatever walls are in view, and then how far it is from the center of vision is from the floor, and then you just triangulate that main point, and then you foreshorten all the units down onto the floor, and you foreshorten all of your units back in space onto this wall by projecting it over with a vanishing point, right? And then projecting these all over with your vanishing point. Each of these units over with the vanishing point. Because you're going to foreshorten all of your units along these 3 axes right here, these 3 reference lines. And then you have to take them from the reference line and move them over to the wall using your vanishing points. So let me get a different color. So these are your foreshortened units on your reference lines from your center of vision. And what you're trying to do is you're trying to project them back along this axis to the wall. And you're doing the same here. You're trying to take, hold on, let me see here. You're trying to take these back to this back wall using your, what was it? This is X, this was Y. No, it was the other way around. So you want to take all your X foreshortened units over backwards in Y. And then you want to take all your Y foreshortened units backwards in X to reach the back wall. And then you want to take both of those along both of these axes and you want to bring those down to the floor. And then once you get them there, you'll have from this location, you'll have a new 0. Right? Your new 0 will be on the ground and back here, right, in the back here. And then you could just make your grid and start building because you'll know now where the back of the room is, and then you'll know how to keep your units consistent. So there's like 5,000 ways that you can find your space, but the main one is just triangulating. And triangulation is just basically this is how triangulation works when a cell tower is trying to get your GPS location. If you only had 2, two cell towers and I was over here, you would only know how far away I was along this line between the two. But if you have 3, then I know how far you are here, and I know how far you are here, which will give us a triangulation. Then I'll know how far you are from here, and then that will also give us a distance along this line that we now have 3 different points to calculate where you're at in space. So essentially, we have 3D space, so we're not only triangulating the y and the z, but we're also the y and the x. We're also triangulating the z. And so every time I move something over and to the right, that takes 2, right? And then when I need to drop it down, then I drop it down, then I drop it back, and then I have to drop it over and then down again in order to get that space. So the first one you can calculate just by 2 axes, but after that you need to calculate 3, right? So I need to calculate over by 1, down by 1, and then back by 3, and then draw my line, and then I have it. So it's just important to note that you have to go over, you got to go back to find that place, and then you have to go down and then back, and then you got to draw down again, and then you have to draw over, and then you got to draw down again in order to get that space. If I wanted it on the left, or if I wanted it down first, then I'd go down to where I wanted it, and then I wanted it to go to the left. Then where it was down, I go to the right axes that I want to foreshorten it on. Then I go to the one that, the unit that I want, and now this is how many ever units down and to the left. Then I need to calculate it back in space. So I have to actually go over and either triangulate over and down or triangulate down and then over. So now I've triangulated over to the right by 2 and it's already down. Then when I draw back like this, then where it meets there is my new unit. So triangulation is the power of 3-point perspective. You need to triangulate. There is no way around it. If you want these objects to adhere to the cone of vision that we set up based on all of the math, right? So we have the center of vision, we have the distance line, we've got the station point, we've got our measure points, we've got our united ruler, and then we've got all of our linear rulers foreshortened using measure points onto our reference lines that are associated with our center of vision. All of that is math, and they're all associated without the station point, without the center of vision, and without your measure points being based off of those things. Then it all changes. So if I change the center of vision to someplace else arbitrarily, right, like right here, and I still have my station points from here, and I still have my measure point here, then it doesn't work. But if I move it over here, then it's inaccurate because we no longer have, the math doesn't work out, so it's no longer 90 degrees. So you can't move it. There's only one place where your center of vision can be, and it's predetermined based on where your left, right, and vertical vanishing points lie. Right? So if you want to move your center of vision, you got to move your vertical vanishing point, your left and right vanishing point until you get it where you want it. And that's just how it works. So we can do that. Let's reverse engineer it. Let's just say that I've got my horizon line here, and I want my center of vision to be right here. What I could do is I'll just go across that point, and then I'll decide where my second point is going to be. So let's say I want the center of vision to be left heavy. That means that the right vanishing point has to be more to the right. And then I'll move that over there. And then once I have, if I know where my center of vision's at and I know where my true horizon's at, all I have to do is create one of those L-shape brackets again, level it up with the reference line that I created, and then meet that other point there. And once this L is at the right angle to this object here, and it meets the left vanishing point, I could just drop that, and then now I know it's at the right angle, and I can move that down, and then I can make another one. This one's going to be a little bit longer because just how it works. So now I have this one, and I can I can level it up with the opposite reference line. Now that that's level, I just meet that here at the other vanishing point, and it looks like our vanishing point is super low, which is good. That means that we're looking more forward. So now let's grab this guy right here, and so I'll just take that line here and then extend that down. And it looks like the right one I have to extend down as well. So if you want your center of vision to be in a specific spot, this is a good way to do it. Oh man, sorry you guys, I accidentally didn't create a new layer. All right. Okay, I think that goes down here. There we go. And so now we have X, Y, and Z with our center of vision over here. So if I draw a line straight up, it should meet, cross right there. Bam, right? So this is just how the math works. There's nothing you could do about it. Once I created that where I wanted the center of vision and I crossed the X and the Y, there was only one option because this is at 90 degrees from that. So I created that line, and this one right here is 90 degrees from this one, and I created that line. And then where they met, it just so happens that mathematically it just lines up. So now we have our center of vision, and now we can start making our distance lines. And once we create our distance lines, remember at 90-degree angles, so this needs to be 90 degrees from that. This one right here needs to be 90 degrees from this one. And then we create our half kite here. Once we know that that's proper and then that's 90 degrees there, which it's not right now, I'm just saying. Once we know where our station point is, we can then find our circle of distance. And now this, where this meets down here, is where that meets here and here. Those are now our three our three station points, and then we can create our halfway to the station point, our cone of vision. And now we know that if we foreshorten anything in this space, and we make anything in this space, that it will be in correct foreshortened perspective. So if I create a sketch first, and I want to focus on the front side of this cabinet, and then I have another cabinet behind that's maybe in an L shape, and I'm going to my vanishing points, and I'm kind of paying attention to how I've done perspective in the past by triangulating space, right? So if this is and that are in line together, then I'll line those up. foreshortening the space appropriately by estimation. Right. Then we have our objects in space, and then we can start putting all of our measurements on there, right? Another way to do this is to take our actual measurements here. So this is the 50th way to create a space, right? The 50th. Like I said, there's a lot of different ways. What we could do is put this on multiply so we can see through it. We can put the unit where we want it on the X and the Y, right? So I don't know where's my measurements? So if I said that my center of vision is right here, that means that going off into the left is going to be the kitchen table. Going off into the left, the depth of the kitchen table, or it is the depth of the building, right? So one or the other. So that means that I can take these units and I can now foreshorten them back onto this bar here. But the problem is that I don't know if this unit scale is correct. So if I go from my station point to my center of vision with this unit, with these units, I have 1, 2, 3, 4, 5, 6 units. I'm 6 units away from the center of vision. I think that's fine. So 6 units from the station point to the center of vision, I think that that's a good unit scale. So now I just put it where my measure bar would be. Right, so my measure bar would be horizontal for anything horizontal, and it would be vertical for vertical. So we will use this one twice, one for horizontal and one for vertical. So I'm just going to put my center of vision on the unit that we triangulated right here. And then we'll go back over here and get the height here, the depth. And I'll put that on multiply, and then we'll just turn these off and on as we need them. Then I think I decided that this was where my center of vision was going to be horizontally going back to the right. So that means that this depth is going to be from the center of vision back. So we're going to have 1, 2, 3, 4, 5, 6, 7 units to the right. And we're going to have going back to Y, and we're going to have 1, 2, 3, 4, 5, 6 going in the front on the Y. Now we're going to go ahead and take this guy right here, and this guy should be oriented with the true height line right here, and then the center of vision should be here. Let me turn that off. So the center of vision should be in the same spot. So here's the center of vision. I decided it was 3 units down, right? So it was 3 units down. So that means from the eye level here, the horizon line down here is 3 units. And if we're looking down, that's fine. And I decided it was going to be right here. So that means these ones were wrong. Actually, we're looking a little more forward, so let's change where we want the center of vision. Because we're looking more forward, maybe we're only looking at a unit downward. Sorry for all these changes. I just figure we'll just use our logic and figure these things out. So that means below the center of vision, we're going to have 5 units down. So let's grab this one, and we have 1, 2, 3, 4 from the bottom, and we've got whatever it was, 1, 2, 3, 4, 5, 6 to the left, and 1, 2, 3, 4, 5, 6, 7, 8 to the right. So this is all in front, and that's all behind them. So this is good. So these units will get foreshortened onto the X reference line by the measure point, and then be lengthened out here onto that reference line. So here I could just do this now. as long as they're all the same, we're good. They just have to be the same. They have to be consistent. Dude, come on. Oh my gosh. Sorry. Oh, what? I need my lasso. That's weird. All right. So now we have two. None of my keyboard shortcuts are working now. Photoshop, you fail me. All right, so this one will be our, I think, what did I say? I said this one was going to be Y or X. So this is going to be Y, so I want my, actually this one should be my X, because I want my shorter part of my room to go on the more steep angle. So this one is going to be X. This one is going to be my vertical. And this one will be my Y. Okay. So we'll get rid of those, and then we'll create our measure points real quick. All right, so this is how we do it. We go, so here's our Y reference line, and then here's our Y station point. So we create our Y measure point by taking this distance right here from Y to the Y station point, and we swing that on up to past the reference line to the horizon. So now we have our YMP. And then we'll take from X to the station point here. And we'll swing that up. And then this will be our XMP. What in the world is happening? XMP, and we'll do the same thing with Z. So we go Z to its station point, which is approximately right there. And then we'll swing that past its reference line, which is right here, to the opposite side. And this will be our ZMP. All right, so now that we've got our measure points, we can now begin to foreshorten. We can foreshorten these measure bars. So let's go Y first, and anywhere we got a tick, that's where we're going to be going. So Y, we need to cross Y here and hit our measure bar down there. 2, 3, 4, 5, 6 going back into the right, and we have 1. Oops. We have 1, 2, 3, 4 going forward on the Y. Let's get rid of all these. So now we have all of our foreshortened measuring points on the Y, going both forward and backward using our plan view. right? So now the other one is going to be, so we're going to have, so that was y, wait. Oh man, you ended up using x for y. All right, so we'll just use this. Since they're the same units, we could just continue to use this. So y, that would be, oh, it's not centered here. There we go. One, two, so we'll go again out here. And these two aren't going to even work, so we're not even going to worry about them. We don't have to go that much forward, but I was just trying something out. So you have that one, so we have two more to add to foreshorten. So that's back and to the right. So this isn't, so now we're using the appropriate stuff for y. So I do apologize. So now we have all of our units back and to the right, and forward and to the left along y. Now we'll do x. Just going to use the same right now. So now we're going back to x here. Here's the back part of the room. So we're going from our measure bar back to our reference line from the measure point. And now we're going to go forward to our xref. And this is where the building starts to really stretch out. So more than 1 or 2 units ends up being way too much, but we'll add that just in case we need it in the future. But now we have our measuring points foreshortened from our floor plan and elevation. So those are properly foreshortened, giving us proper perspective here, which cannot happen if it is not, if you are not using your measuring points and your cone of vision and your center of vision and all that good jazz. So this one's actually Z, not V. Let's go ahead and turn that one on. And now we've got vertical, and we've got a certain amount below and a certain amount above. Since we're looking down, it doesn't really matter. All right, so this is the Z needs to be flipped. So we'll put a little rotation matrix here, flip it to the other distance line. And then as high up as we need to go is from the Z measuring point across the measure bar and to C. So we talked about that before. This right here is C. So that means that this is the eye level, right? So that means we will not see anything above eye level no matter what, as long as we don't draw above the horizon line, which I suggest as being the appropriate method here. So we're trying to get these units onto the vertical reference line. So we're going to start with the lower unit after we've got the top unit. And going back in space, we cross the reference line and go to the measure bar. right. So now we have all of our foreshortened units, all the ones that we need on our vertical reference line. And what's great about this method in particular is we already know where the center of vision is at in space, so that gives us an edge. We now can block in the very back walls because we know the extent. This is the very back right unit, this is the very back left unit, and this is the very bottom unit down here. So it'll be really easy for us to find that back edge and then start projecting these units over to that back wall, and projecting these ones over to this back wall here, right? So I'll just start projecting some of these things, and hopefully this will make sense. So this right here is our back wall at our reference line. So this is the reference line touching the back wall at 1, 2, 3, 4 from the back left. So it's 4 away from this side of the wall. And then we still have 1, 2, 3, 4, 5, 6 units in front over here, and we have 5 units behind, right? So let's go ahead and go from the floor now back. There we go. Now this is the back ground, so that's the back right corner. Let's do the back left, so we know where the ground is, and we know where the back of the wall is. But remember, this is not the front and right and left of the cube. This is in the middle of the cube. So now we need to grab these two up here. So that's the back there. This is the back here. And then now we know that if we connect these 3 parts, so from this corner back, right, so from here to this corner, we have the back bottom edge of that wall on the Y. And then if we go from here to this back corner, we have the right back. Right? And then if we go from this corner down, it should meet in that same area, which it's not. It's slightly off. Oh, because I didn't make it there. It's not correct. Right there, bam. And then this will be the very back corner of that wall. And we'll just, it's a little bit off, so we're going to just go based on the floor here. And then you'll have to start fudging some things a little bit. So check it out. We have the very back corner of this wall. So that means that I can start building things on this wall if I can project the units. So if we go back to our graph up here, and if this is my center of vision, and this is my back wall, right? And I'm seeing from here to here and here to here. So notice this is the longer edge, and this would be the shorter edge. So that means on the shorter edge over here, I can start putting my refrigerator, and on the longer edge, I could start. So the refrigerator is 2 to the left, and then another 1, 2, 3, 4. So it's 2 and 5 on that left hand wall. So let's go ahead. Actually, yeah, 2 and 5 from this corner. So that means from that corner, this is going to start getting real hairy real quick like. So let me turn off some of these things that I don't need anymore. All right, so we got rid of those, and Uh-oh. Ooh. Oh, that's right. Sorry. My bad. I didn't see it. All right. So if this is the back corner, right now it doesn't look obvious, does it? But we do know that we're using the very back units here. So if I want the refrigerator on the on this right side right here, so I basically flipped it. I mirrored the room. It's flipped vertically on an accident. So if I did that, I would actually redo the space, because I don't like when if I say I'm going to do something, then I'm going to do it. So I would actually flip the space. I would do this again, so that I rotated the camera where I have my longer edge to the left and my shorter edge to the right. But that's not the way that it's working here. So it's a little bit flipped. We're mirrored a little bit. So on this wall right here, let's actually do that. Let's do 3 units over here, or 2 units, and then we'll have our refrigerator. And then, so 2 units over our refrigerator will start, and then 3 more units over our refrigerator will end, and then it'll come out in space like that, and then we'll have our table probably right about here. So probably right about there. And then we'll start moving from there. Now this is a very difficult concept for most people, because look at how close that's lining up to the original reference lines. This is something you have to get used to. You have to understand that we are not measuring directly from these measured units onto this line here. We actually have to move them down and then over to reach there, then down and then over, and then we'll reach there, and then down and then over, and then we'll reach there, and then down and then over, and then we'll reach there, right? And then down and then over, and it'll reach that back wall, so on and so forth. So we have to keep doing that whenever we want to measure something. So, but what's great about this is now we know where that back line is, so we could start projecting our units backwards in space. So if this is my back wall, then that means that this is the unit in front of the back of the wall. So let's give it a different color, because we're going to be projecting these units down into the right, because we need all of these units. We need all of them here, right? So I'm just going downward. So I'm dropping these down to the ground by going down in Z. And then I'm going to cut over from X to this bottom unit right here on Z. And now wherever these lines meet, that is a unit that needs to be taken back in this direction on Y. And wherever these meet this line is now the new unit back in space. Okay, so now that we have that, we could just sort of circle those places right there where they meet that back wall. Hold on. All right, sorry about that, you guys. Someone was at the door. All right, so now all of these units that are up here are now down and backwards in space along that back wall. Now we have to do the same thing with the height. We got to project those back to the back unit here, right? We have to project all of those back in space. and then we project them over to the back corner. So let's go ahead and do that now. So I'm still going to use the yellow that I was using before. So this is how, so along this back wall, right here at this unit, notice that what unit it is? Right here at this unit. What happened? Hold on. It's not working. Boom. All right. I think that color might be too light for you guys. We'll do red. All right. And then on this one, I will change the color of it. Can I use this? Are you kidding me? Please. There we go. So we'll colorize this. We'll make it a little bit darker here. And more saturated to give it. Yeah, we'll do that. That's fine. So now we're going to go from Z up to the last unit on Y on the reference line. Now here's where I hope that you guys are starting to understand what's happening. This is the first time that you guys are seeing these things connect. So this is the furthest unit back on Y. And if I go down to Z, notice how it hits the floor here, and that where it hits the floor, it's 1, 2, 3, 4 units back. Notice from center, it's 1, 2, 3, 4 units back. That's an important distinction. So now we're going to go from the first unit back to Y. So we already have our foreshortened units. We don't need to use our measure points anymore. We're using our vanishing points, but we're going from every unit back in the direction that we want it to meet that back wall. So we have a coincidence there. No, it's not on the same space as the floor line on the left. But notice how it triangulated right there. So this is a swath in space that is not at the back wall. Only this line right here is at the back wall, and it's not where we want it to be. We want it to be on this line because that's the back corner. So now we'll take it back. I'll get another color here just so we can see the separation. We'll do green. All right. And then we'll go back to X from these marks right here. As a matter of fact, I can now cross all the way forward, and I know that because this is along that wall and it's divided into these amount of units, I know now that these lines are in fact 1 unit apart, except for this one right here from C. C is the eye level. So we're going to go across this next one right here. So this is where we're starting to see how all this sort of connects. Did I create a new layer for this? Yes, I did. And I think I'm not crossing. I'm seeing double here. There we go. So I'm crossing this unit, that unit, that unit, that unit, that unit, all the way back. All right. Now I can erase everything past where it meets that back wall. And I could also go back to the blue line here, and I can erase everything past there. And then now we can get rid of the red there. and then we can, because we have the units already projected back here and up there now, we now have that back wall. And then because we have these units, we now have this wall going across, but we don't have these units back here on this. So I'm going to go ahead and start projecting those downward. We'll keep it green on that back wall. So we're going to go from Z up through each of these units up to the horizon line. Z through that next unit where it meets that line down there. Z up through there. And the next one is over top of this line right here, just slightly to the left. All right, so now I can get rid of all of this that's down below the blue. Okay, now for Y, let's use, normally I use green for X, blue for Y, so we're going to use blue for Y. So we're going to go, we'll be on another layer, and then we're going to go from Y backwards, forward, through each of these units, along this back wall, right? So we'll just go from the bottom up. All right, so now we have the left wall divided appropriately at a specific distance back behind us. Now you're starting to see, hopefully, all of this space start to really develop. We could also do the Z real quick. This will make more sense. So I add another layer. Yeah. So each one of these on the ground now, so I'll make the floor red. This will be the Z plane. I'm meeting it where the mark meets the blue line down there. So at this point, there should be no problems as to what is actually happening here. You should be able to tell what is happening, what's going on. So now we need to take these foreshortened units here and we need to push them down and back over there. So let's do that. So we're going to use red again, and we're going to go from each of these units here. So this one we don't have to go from because that already exists back in space by the amount that we need. but we do need this unit that's attached here. We need that down here, right? So this is going to receive the units from the upper reference line. So from the upper y, we're going to recede them down to the lower y, and then we'll push them back in space to the left wall y, where it meets the ground. All right, so let's do this. So from number 2, we'll move that down to z. 3, we'll move that down to z. 4, we'll move that down to z. 5, move that down to z. 6, down to z. 7 down to z. 8 down to z. And 9 is already down to z because that's the vertical reference line. Then we have 10, unit 10 down to z. We have unit 11 going downward to z. We're going, all these lines are parallel to each other, so they equally divide the space down here. And then I'm going to stop where I think this meets. So it looks like it's going to meet right there. So we'll take this one down to z, and then we can then project all these back over there. So this one, here, let me change the color of this so you guys can see what's going on. So we'll make these, blue, and then that way the red will make sense. All right, so now we're going to go from X out to this lower projected unit down here. Go from X down to this lower projected unit here. X out to this unit here. As a matter of fact, we can now just make the floor. Let's do that. So I'm going to bring this way out. This way out here. So it's meeting right there where we took this unit down here, and then now we're bringing that unit back to this wall, and it just so happens that that's the floor, and then we'll use that to create that back upper division as well. So X through this unit right here and out. X through this unit on the ground here and out. X through this unit right there and out. X through where the center line meets the ground, which is, I believe that's unit 9. And we have 9 more behind it. So X through that unit, just call that 1. X through this next one, call that 2. X through this next one, we'll call that 3. X through this next one, which we'll call 4. X through this next one, which we'll call 5. X through this next one, which we'll call 6. So there's 8 in front. This one's going to be 8. And right here is 9. So there is 9. So we have 9 units right there. But we're not putting that one on there because that's the back wall. Then we can just erase everything that's touching this up to touching that back wall. We're good. And we can get rid of the blue as well. Whoa. Please don't tell me it's on there. It is. Dang it. All right. Going backwards. Sorry, you guys. I hit Control Z after I hit a new layer, and then Control Z bumped it back. tell you, I'm a madman. All right. So start there. Just basically do the same exact thing that we just did. Try to do it a little faster. Since I'm doing this all real time, it may be boring in some areas, but at least you get to see how things develop. And then I can show you like issues that I see that's in the wrong spot, that a lot of people have when they jump from 2-point to 3-point. Because there's an added dimension, it's no longer as simple as finding two axes and then meeting a point. You actually have that third axes to deal with, which can be very tough. Okay, so now I get to erase everything that is behind that teal line there, and then we get to get rid of the blue. So we brought this down and then back, and now that it's on the back wall, we could actually get rid of all of that. We could even get rid of maybe I drew them separately, maybe I didn't. I don't think I did. So even if I got rid of that, I still have my cone of vision. I know how big my cone of vision is. I still foreshortened using my station points. So now if I get rid of all these things, I still know that all that other stuff still exists in proper perspective. Right. So I still know where my cone of vision is. I still know where I can frame things. But now I don't need those, and I have properly foreshortened space in space. Right. So there's my bottom plane, and then this is the beginning of my side plane there, which we're going to use blue for. Because that's what we decided. And we know exactly where they meet along that back left wall now, right? So now we just go from Z up through each of those points and then erase everything that's under that back wall when we're done. And then we can start building our space. So this is one way to create accuracy and know what your unit scale is, and then know exactly how far back something should reside, just by using the floor and elevation plans and projecting them back into space accordingly. So wherever those plans meet that center line, or that vertical vanishing line, or the vertical reference line, we then now have a measure bar to work with that will help us know how far forward or how far back things are in space. So I just chose an arbitrary point based on what I thought the viewer was seeing, and now based on the angle that I wanted him to be at. So I guess it wasn't so arbitrary, but it was arbitrary enough. It was a choice. Wise man once said, "A choice is better than no choice." And I think that that is absolutely true. All right, so this will be the the YZ wall. This will be the XY wall, or floor. So I could actually say that. This would be left back wall. And these two are the XZ back right wall. Okay. Now that we have all this in place, anything that we draw, as long as we draw it appropriately because we've already made all the decisions, will be in correct perspective. So let's go ahead and look at this. I'm going to do this corner is the back corner, and then this is the left wall, and that's the right one. I guess if I did this, this would be the deeper wall, and this would be the more shallow. Or this would be the deeper wall, this would be more shallow, so we'd actually be looking more at the refrigerator. Let me think. What do I want to do? Yeah, we already got this. This as being our long wall, and this as being our short, so we'll start in this corner. Like I said before, if I was to do this again, I would actually do this in the corner and put the shorter wall that way and the longer wall this way. And in doing so, this the center of vision wouldn't be to my left, it would be to my right over here. So the table is basically going to be here, right? And the refrigerator is going to be here, and the open door is going to be here, right? So let's just do this. So we have cabinets are 2 out away from the wall, and maybe the refrigerator won't be the refrigerator will be on the right. Okay, and then it probably won't even be in view. So we have 1, 2, 3, 4, 5 away from the wall. 1, 2, 3, 4, 5. This would be where the refrigerator's at, and it's 3 deep. So even if I added that there, it wouldn't show up in the picture. Okay. And then we have 2 deep here. We've got 2 away from the wall here. And then this goes back all the way. So it goes 2 and then 2 more. And then another 2. So it's in 2s. So 1, 2. So we got 1, 2. So that would be where the stove starts. And then 1, 2 here. This would be where the stove ends. And then 1, 2. This would be where the sink starts. Right. So stove here. Sink here. 4 units. Right. So this is the 4-unit sink, but this is on the ground. Right. And this is the empty counter space, and this is the stove on the ground. So now that we've got all this stuff marked, this is the refrigerator extends. This is where the cabinets move forward again, and it's only 1 unit to the right, so we're good. Now we need 3 units, 3.5 units up. So this is how high the cabinets are. All I have to do is now start plotting this stuff. So here we go. So we're going from Y through the halfway point here, that 3.5. So that's the countertops. No, it's not, because it moved. That would be the countertops. So this is where it meets at the corner. I now have the countertop backs there. Now let's do the floor from the X and the Y. So this is the cabinets. This is the front of the refrigerator. And now we can erase all this out. Erase that out. Erase this out. Cool. And then we can also erase this out right here, because it's 2 units to the wall. All right. Now we're cooking with gas. Okay, so first thing we need to know is where these two line up, right? So this is 2 from the back wall. So this needs to be 2 from the back wall, and this will give us that front corner. So we'll go up from Z through that front corner there that we have, and then we'll just move it up to where we think those will cross. We'll do the same with the refrigerator. So I'm going to just continue that up because the refrigerator is taller than the seam. We'll continue this up here as well. And then we will continue this up until we feel like it's the front. And we'll continue this up as well until we feel like it's hitting the front. And we'll do the same back here behind the refrigerator until we get all that stuff aligned. All right. So now we'll go from X through that point in the wall, and we'll just take it all the way forward. And now where it meets all of these points in space right here, then that's exactly where it'll be. So all of this is actually behind. So that's good. We could just get rid of that. And that's in front. And this is also in front here. Just get rid of that. All right. And now we'll do, since we know where they're at on the ground, we can erase from the ground all the way down on all of these. We can also get rid of this one because we know that that's behind. And we can get rid of these right here. And that one. So what I tell a lot of my students is make sure that you're putting these on separate layers instead of erasing like I am right now. So now we'll grab this corner here, and where it meets that edge is now the front. And then here's the side. And let me see, where's that back wall? So this is within inside the shape. There's some overlap here, so we get rid of that. And then also this here. We don't need that anymore. And now we have all of our shapes blocked in that side appropriately. So now we'll go from this corner because we know where that corner is. And we'll go from Y forward. And that will give us 2 units forward in space at that height because we triangulated it. And now we can go from each one of these spaces here. So each one of those ticks, we'll just trace that up. And where they meet the next level, that is where they cross that next line. That is where we'll go back in space. Do the same thing over here. There's a lot of coincidences happening right now. That happens. There's nothing you can do about it. You just got to work through it. That's why using different colored everything is really important. All right, and now we will go from there to the front using X. And all of this is accurately foreshortened. And I had to use other units, other places to foreshorten my units because right here, this is the halfway mark. So I had to use these down here to, and then the relative position of all this in order to make that all happen, just because of where everything is at. It's funny what happens, like you feel like it's wrong until you erase those lines or get rid of them or draw over them and turn them off. All right, so let's see here. So now, oh yeah, I gotta go to here because that is, this right here is my stove. This is my sink, and above over here is going to be my, so that would be right here. That's where my cabinets lie. They're a unit and a half up. So we'll draw this a unit and a half up along the wall, and then we'll do the same thing on this side. And since that's hidden, we're good to go. So this doesn't look like it's touching the wall because remember, it's a half a unit up. So now we have to, because it's a half unit up, it's going to be a little bit different for us on that particular edge. So now that is the back corner. We're going to have to draw forward, so we have to find 1 unit forward, which that's where it's at, and then draw from here at the 1 unit mark forward. And then we have to do the same here, 1 unit forward there, along that back wall. And that is where the front of our cabinets, we're not going to see what's behind it because all of that stuff is going to be hidden, foreshortened. So I'm going to keep this back here because I don't have to cut the, I have to cut the cabinets off here, but I already know where they're going to be at right there. Now some of these aren't quite lining up, like this right here should be on that mark there, which is telling me that that something is a little off, but I'm going to compensate for that by making sure that everything is equally off. Okay. All right, so you know where that's gonna stop. So we'll bring this forward at that location. And this will give us our front edge of these cabinets. And then we can erase behind them and in front. There you go. Do that same thing, right? If we trace that up, right there. Because that only makes sense. So you have to keep an eye on the space, or it just won't work. All right, and now I could just grab this edge here, draw that up, since it's a little bit further back. And then also on this one right here, draw that back. And then now we have this particular cabinet. And I can remove that back line there. All right. And then we'll just bring that corner up. And we'll just keep doing this and doing this until everything is plotted correctly and we get something that looks accurate. And then we frame it where we'll want it to be framed. Give me this. So in this particular case, I would probably want it to be framed like this, just because of the eye level. And I know that this would be a little bit out of perspective, or out of, it'd be more in the wide angle area, but everything else, everything that's important, everything that's all right here will be in the standard area. And then I can start adding junk here, and then I can add, whatever I want in this direction, and then this will start to give the space a good feeling and an appropriate perspective. Right. So that's basically, there's like 2 more ways to do this, but I think this should give you enough to chew on. The main concern, the main thing that I wanted to show you was that you absolutely cannot arbitrarily place the center of vision. You need it to be placed in accordance to everything that you've been taught. Hold on, let me get this. Where did I place? Okay. You need to place everything according to the rules of 3-point perspective. We need everything to relate to the center of vision. And so what I did here is, once I got the center of vision in the correct place, and I had the correct cone of vision, and I had the correct distance for my distance lines, and I found my center of vision, which, remember, I started with my true horizon and my center of vision, and then I reverse engineered the Z. I realized I was looking more towards the scene, and then I took parts of my elevation and my plan views, and then I placed them accordingly on my height line and my true height line and my general measure bar, right? And once I had all these in place, I just foreshortened them onto these reference lines, and then I took the very far units because I wanted to make the back wall, and I projected that until I found it. And then I projected all my foreshortened units down and over, from my X reference to down to the floor, and then over to the back wall. And then I took my Y reference points down to the floor and back to the wall. And I took my Z reference and I went back to the wall, and then I created my grid. So it's very important, very, 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 very important to understand what you're after, so that it's very important to understand not only what you're after and to keep that in mind, but also that I can only foreshorten with measure bars that are connected to my center of vision. And I have to then project it back and over and down and up to reach my grid. So I hope that this was helpful for you guys. This was just some tips and tricks. It was hopefully to fill in some gaps. This one's long and arduous, and it can get really, really difficult really quick. So make sure that you keep your workspace organized. And I assure you, I want to emphasize this, even though this is hard, once you do this enough, you won't need it anymore. You can eyeball everything that you do with a high degree of accuracy, sophistication, and proper lens choice. So that means that your depth will fall off properly. So the more you exercise in this space, the more you exercise in different cameras, the more you exercise these perspective constructs and you choose these things and you find out what works and what doesn't, and how the distance of the vanishing point changes the depth, the difference of the vanishing points, how distant they are away from each other and from the center of vision, how much longer the lens will feel, and how working with inside the cone of vision is important for creating realistic spaces. Once you start getting used to that and you really hone this skill, you won't need to do this but maybe more than once every 6 months or something to just refresh yourself. It's like anatomy. You do all this hard work in learning anatomy so that you can draw the human figure, and then you start doing all this academic human figures, and then you slowly evolve out of that, and then you become so accustomed to it that you don't have to recall. It becomes natural. You don't have to continue recalling all of the names, and you've done enough study to where when you draw, it just makes sense, and you do it intuitively. That's the same thing here, and if you learn it, I can guarantee you better things will come your way. So just put in the hard work on this, get used to how the space works, and move space around from the correct location so that you start to develop an idea of correct foreshortening. If you don't use the rules, then you're not creating correct foreshortening, and therefore you're not really learning the proper. You're not learning how space foreshortens correctly. Then you're going to get nothing out of it. You're going to do all this work, and if it's not done correctly, then you won't get anything out of it. But if you do it correctly and you really invest yourself in it, then chances are you're going to be really good at it. And people will say the word talented a lot, which you guys know that I hate that word because it negates all the effort that you put in. But you're going to get that word talent. People are going to say, oh, you're so talented. And they're not going to have any idea that, no, it's all skill and it's all based off of my correct training and my efforts towards that correct training to give me realistic results, or at least convincing results that I can create these imaginative worlds in. And so that's where you want to be. You want to be at a place where the hard work is invisible, so invisible that they think that it's all talent. That is where you want to be. And this is one way that you can get there. You get really good at this stuff and you use logic, and you excel and you become better than the thousands of people that are doing this, that are doing an okay job, and you become a professional. You become a top-tiered artist when you start learning these foundations. And I think this is one foundation that has been lost to time because a lot of people are lazy and they think that just using 3D is going to get them there. But if you use 3D as a crutch, you'll never be proficient out of the gate at drawing a picture from imagination. You'll always require the 3D object. And it depends on who you are. If you're just a designer, use 3D. Just don't even worry about it. Just use 3D. But if you actually want to make physically accurate pictures from imagination, and you want to do it fluently and quickly without the need of stopping and learning another program and waiting for it to update, and when it updates, then you have these 20 other things that are brand new or that change that you got to figure out how to, constantly adapt to that. If you want to learn this and you just put the effort into this doesn't change. It's always the same. There's no software to learn or relearn or get better at or figure out or adapt to. It's just this, and then you learn it really well. You create beautiful pictures that are accurate within reason, and then you stand on your own. It's just like someone who's a good character artist. You can tell who's the best because they know their anatomy and they sketch from real life all the time. And so this is anatomy for sketching environments. You do this, and then you learn how to sketch environments, and you do it often, and then you'll have the ability to control your space and the environment that you're trying to create, and the world becomes lush and big and beautiful and controlled and exactly what you wanted, instead of just sort of falling on bad habits and hoping that you come out with a good image. This way will give you a good image 90% of the time. And then when you learn how to commit this to your memory and it becomes more intuitive, then it's 100% of the time that you'll create something that's at least convincing. It may not be beautiful, it may not be designed well, but at least it'll be convincing. And you won't have to worry about the language itself. You'll be using the language to communicate ideas. And then that's where you want to be. That's just where you want to be. So if you need to review this a few times, you could even put it on 2 times the speed, but I would suggest that you listen to me while I'm talking, even if it's chipmunk style, and really become fluent at being able to move foreshortened units around your space. The same thing exists in 2-point, but it's a little bit easier, and 1-point, which is a lot easier. But keep in mind that a few other things. One is 3-point perspective lends itself to wide-angle lenses and standard lenses, not necessarily longer lenses, unless you're doing an establishing shot from like a helicopter or something. Then you can use a long lens. But in general, if you're in the space, it's going to be wide or standard. If you're far away from the space, it'll be long. In 2-point, standard and long lenses are the best. But the longer the lens in 2-point, the more you should probably just use 1-point. And 1-point is it's generally good to use a shorter long lens to a longer lens in 1-point perspective, because it's just the way that the perspective is set up, and it lends itself really well to it. So those are just some things to consider as you start making your choices. And I hope that this was helpful. I'll come back with another much easier way to create a grid in a few weeks. But I want you to get used to this before you move on to the easy way, because the easy way can get incorrect really fast if you don't know what you're doing the technical way. So this is the technical way. You got to learn how to deal with the technical way, and then we can do the somewhere in between technical and artistic a little bit later once you're up and running. But thank you guys so much for watching this video. I hope it was very helpful, and I hope you weren't bored to death, because this is a very dry subject, and one that there's no other way around it, and I do my best to communicate it in an interesting way. But I hope you weren't too bored, and I hope that that you can see value in it, and that you'll hit that subscribe and that like button, leave some comments and some feedback. And as I move forward with these tutorials, I will add to them as you guys request examples and things like that. So anyway, so we'll see you in the next one. Thank you so much for watching.